So let me jump forward here. So now from here, what we want to do, now that we've determined what that base application depth of water should be at a given point in time, now we want to take this same EM soil map and say, how would we divide this field if we were going to do, for example, our VRI speed control? And what that looks like in this particular case is something like this. This is what we call a 60-sector VRI speed control prescription. Prescription's what gets loaded out to the sprinkler controller that allows us, in this particular case, to manage the speed or application depth of water every 6 degrees within this 2-acre sector. Again, the advantage of this type of technology, this type of control, it's very simple to do, highly reliable, and I'll talk a little bit about what type of controllers that allow us to do this. With our partnership with Valley, of course, all Valley computer main panels would have the capability to load up to 60 sectors prescriptions with the new software upgrade. Also, the PivotTrack GPS, the newer GPS devices, can be installed on the end, and they also have the capability to do the 60-sector speed control. So what that means is, for those of you that may already have PivotTrack or upgrading to a PivotTrack GPS, you have basically VRI-ready capabilities on that system. And we can do this once we have that EM or EC data collected. So this particular prescription, and I'll back up here, you can see what it's doing here is, in this particular case, and this is a field in Nebraska, what it's doing here is it's basically in these areas here, it's running a slower rate. Pivot's running slower, applying a little bit more water. And if we look back in these areas here where we have the higher EC or heavier soils identified, it's going to speed up a little bit. So really the concept here, very plainly, is where you have variability, we have now a very precise way using high-resolution data and precise GPS positioning to basically allocate the water to different parts of the field depending on whatever variability you want to address, whether it's field variability with respect to soil and topography, whether it's a climate variable, whether it's some type of in-season crop variable, and I'll show you different examples of that here momentarily. So that's a real basic prescription. Keep in mind, as I will show you here in a minute, these prescriptions will change, and they'll change based on different factors throughout the growing season. So this isn't a one-size-fits-all or a one-time upload of a prescription. These are things that, if managed properly, managed agronomically, we want to keep adjusting through the season to make sure that water is fully optimized. So going back to our DPM layer, the second level of variable rate irrigation would be the zone control. And this is what Valley introduced last fall. And that is, again, the ability to now break this field into much smaller blocks. Now, if you can see this, in this particular case, you can see each one of these little rectangles here represents a different application depth. And what's unique about what CropMetrics provides is the ability, once the Valley VRI zone control system is installed, and it can be installed on any electric drive center pivot, we have the ability to very quickly, through an automated process using the software, to generate a prescription that can, in this case, as you can see, much more tightly capture those soil variances or any other variances that we want to bring in through the data. So now again, same as the speed control, these prescriptions can be adjusted, and they can be adjusted very quickly. In this particular case, we can manage, on this particular pivot, over 5,000 individual zones. And so we have the ability to, for this particular example, we can change the application depth across 5,000 different individual zones within a single 130-acre pivot, and we can do that as frequently as needed based on the data and the software. And this is really, to us, this is the enabler that allows us to agronomically apply the water using VRI versus simply applying the VRI for non-cropping areas. So So that's the zone control and a sample zone control prescription. So talked about the EM survey. Some of you may be familiar with what's called a Veris EC. An EC cart basically drags across the field. It has coulters, it goes through, and it measures the electrical conductivity. EM, very similar. You pretty much get the same result. What this is here, basically this is what's called an EM38 sensor. It's about an $18,000 piece of electronics equipment here that sits in this all-plastic sled, and then it's dragged across the field. And what it's doing is it's putting out electromagnetic fields that penetrate 3 feet down into the soil profile, and it's simply making a measurement of that conductivity, that soil. The tighter soils, the heavier soils are going to read higher on the scale. The lighter soils are going to read lower on the scale. And what we really want at the end of the day is variance. How different is this part of the field from this part of the field from this part of the field? And we can measure that very precisely. So basically this sled is going to be dragged up and down the field. Goes in 75-foot transects, collecting a data point every 1 second. We measure 3-foot deep EM, we measure 1-foot deep EM, so we get the topsoil and the subsoil map, as well as in this particular case, we're also collecting RTK elevation data. And the RTK elevation data is very important to this process as well, because it gives us that sub-inch accuracy that we can convert into different topographical layers that we can use to further adjust management of the water. So keep in mind this is a one-time collection. For those of you who aren't familiar with this, basically this is really, as far as the program, this is the only time we really ever have to go out to that field, and that is to do this one-time collection. Once that data is collected, it should for the most part be good for the life of the field, and then that data can be used for anything with respect to precision farming that you might want to apply, whether it's fertilizer, variable rate seeding, and even water. So, so kind of the first step, what we do once we have that EM data back, before we start talking about what level of application control might be the best match for that field, is using, again, some of the precision tools. What we want to do is we want to assess the variability. And really what we're saying here is based on the identified variability through the EMEC collection, how bad a field is this? This is a pretty standard practice. So what we do is we do what's called a wetted area raw field variability calculation. And essentially we're taking those EM values, and it's a pretty standard formula, but it's looking one standard deviation divided out by the average, and you come up with this percentage here. That number probably doesn't mean a whole lot just looking at it, but it's a good reference point for us to say, is this field worthy of variable rate irrigation? And so in this particular case, for this particular field, again this is about a 127-acre circle, we calculate a field variability of about 12.8%. So a field that has only one soil type with no variability would basically be 0%, and then it goes up from there. Our rule of thumb is basically we look at this and we say, well, any field that registers 5% or less variability, we don't recommend any type of variable rate application control. There just isn't enough variability in the soil to justify the cost of adding the variable rate. Anything above 5%, definitely anything above 10%, we say is a good candidate to start looking at what are our other options. So the next thing we're going to look at is we're going to take that same field, but instead of flat rate applying our water to this highly variable field, we're going to say, what if we break it now into 60 sectors, effectively 60 fields with respect to water and even potentially nitrogen fertilizer. So now what we do is we run the same calculation, but we're running it in a much smaller management area. And so when we crank the numbers on this particular one, we see a reduction for this field all the way down to about 6.4%. So what we're saying is, we know as far as the soil is concerned, that's not going to change. So to address variability, the only option you have is more precise application control. And if we can control our water every 6 degrees through a prescription like I showed you, our claim right here is that we can reduce that field variability by about half. So what's that really mean? Well, this basically to us quantifies what the opportunity is of this field. Now, does this mean a 6.4% potential increase in yield? Possibly. We're making the field smaller. We're managing our water more precise to the needs of that soil. That's really the goal here. It's kind of a combination of saying, can we better utilize our water, increase water use efficiency, and can we optimize our yields, get more out of each of these individual sectors through that management control. So immediately we would see for this particular field, absolutely you want to look into a little higher level of control, variable rate control. The next step we take is we say, okay, keeping with those 60 sectors, what happens if we bank our sprinklers into these different zones, which again allow us to now control our water in a much smaller, tighter management area. And if you look at any one of these blocks, as you can see, there's a lot less variability simply because it's smaller. We rerun our calculation for this, and we see in this particular case, by managing our water for this, it's roughly 360 zones. So from going to one flat rate to 60 sectors to 360 zones, we calculate field variability about 1.6%. So with this right here, on this particular field, our claim, very simple, is we can pretty much eliminate variability, again, with respect to water and potentially nitrogen. So I would say for this field, there's an opportunity for any of these two. Again, this one, you have a pivot track GPS, you're ready to go. Very reliable. Again, we're not changing flows and pressures. And it's very easy to tell that this, that you're managing to this degree. This requires a little bit more equipment. It does require the Valley Pro 2 computer main panel, a series of control boxes, and a series of Aquamatic valves to be able to, again, bank these sets of sprinklers and cycle the rates. So a little bit more involved, but again, think about it in terms of benefit. If the variability is there and the dollars work out, it might be worthwhile to step into this. Or you can start with this, see if you like it, and then move to this. We can even do a hybrid of these two. We could add zones just to the, say, the last two spans, so we can speed control everything in here, reduce cost, and do a variable rate zone control right there on the edge of the machine where you're going to encounter most of your acres. So, so there's lots of options, but definitely the variability suggests the speed control. So.